Okay, so we're going to solve this system with elimination. As always, I want you guys to write these down. Even though it's already written, write this on your paper. I'm going to use the virtual paper or the virtual whiteboard here. So, and we want to line these up also when we write them. 6x, put the negative 5x right underneath it, please. And then we have a negative 10y, and then put the positive 10y right underneath it. And then we have equals 12 and equals negative 5. You could write the whole thing at once or line them up the way I did. So, again, this is called elimination. That means we want to eliminate a variable. That means we want to get rid of one of the variables. And I want to remind you that sometimes we're going to eliminate x and sometimes we're going to eliminate y. Now, in this problem, we're going to eliminate the y because we have a positive 10y and a negative 10y. You know, if we had a negative 5 and a positive 5x, we'd eliminate that, or positive 6 and a negative 6x. If those two numbers were opposite that are in front of the x, then that's what we would be. That would be what we would eliminate. And this problem is going to be the y. So we have opposites the way we need them. And just let me say, if we don't have what we need, and we're going to see those kind of problems in a minute. When that does happen, if it's not the way we need it to be, we will make it to be the way we need it to be. This one's already set up for us. So all we're going to do is add everything across the board. We're going to add these two in red. We're going to add these two in green. We're going to add these two in blue. Okay? If we add up the two reds, 6x and negative 5x, we just get 1x. And by the way, I'm not going to write the 1. I'm just going to write x. If we add the green, we get the easiest number in the world, 0. We don't even want to write that. We just want to cross it off. And if we add 12 and negative 5, we get 7. So we're halfway done. We have part of our answer, x equals 7. Okay? Now, what we want to do is go back to the original two equations, and I'm going to kind of highlight one of them with different markers here. Either this equation or that I marked with the blue, or this equation, which I'm about to mark with pink. Either one will work. Kanai, why don't you tell me which one you think you would want to work with? Both are going to do. Which one's easier for you? Kanai, the blue one? Which one do you like better, the blue one or the pink one? All right. I'm going to write, and I want you to write it on your paper. Okay. Also, I'm going to write that blue equation on my paper, on my virtual whiteboard here. But watch how I write the x. I'm going to put 6x, but I'm just going to, for the moment, I'm going to put the x inside of a parentheses. Minus 10y equals 12. And now, Kanai, what does it say here? We just said it a second. It's in yellow, by the way. What does it say that x is? Right, so when we see x, which we can clearly see it's in that parentheses, I'm going to erase and replace. I'm going to erase that x and replace it with the number 7. There we go. Replace it with a 7. And now we're just going to simplify what we have, but I'm going to move this around so we have a little bit more room maybe. Okay. So we're going to simplify, like I said. 6 times 7 is 42. Let's go back to black. 6 times 7 is 42 minus 10y is equal to 12. So now we have an easier equation because, first of all, it's only one equation. Second, it only has one variable, one letter, and that's the letter y. So we need to get that y by itself. We need to get the part of the problem that has the y by itself. And to do that, we want to subtract 42. Now, they didn't say this. They don't say anything, but that's a positive 42. You don't have to write the plus, but just know that it's there. And so since it's positive, that means they added 42. They really added negative 10y and 42. But since they added, we want to subtract. And we want to do that to both sides. We want to subtract 42 from both sides. Okay. And again, I need more room here, so let me just keep scrolling down. This will add up to 0. We can just cross it off, simplify it. This is negative 10y, and if we add a negative 42 and a positive 12, I think we're going to get negative 30. Negative 30. Okay. I'm sorry, there's my y. I forgot my y. Negative 10y. And so now we just need to divide both sides by negative 10. Divide both sides by negative 10. The negative 10s will simplify, and we'll have the y all by itself like we needed. And a negative divided by a negative is a positive. So that's going to be positive 3. And so we have a two-part answer, an x and a y. We already did the x a minute ago. The other part of our answer is y equals 3. Let me zoom out for a minute here. And so remember, just like as in the alphabet, the x comes first. So our answer, our solution, will be 7, comma 3. And that will go, I'm just going to zoom in here. When you put this on your IXL, that just goes in here. Put the 7 first, and then the 3. Okay. Now I'm going to say one more thing before I wrap this little video up. Is that you should, I'm going to make sure I emphasize that word, you should always check your work. I don't like to say have to, but oh, that shouldn't even be here. But if you ask me, Mr. Boggs is right, I'm going to tell you should probably check it if you want to know if it's right. So I'm going to go ahead and show you how to check this. We have said here that x is 7 and y is 3. So what we should is that when we see an x, we should write 7. When we see a y, we should write 3. And I'm going to do that in the original problems. I want to emphasize the word problems, plural, both. You want to substitute this into both. It has to work in both, or there's a mistake. We made a mistake, or it's wrong, or something like that. And so I'm going to write those two equations again. I'm going to write them again. And just for the moment, I'm going to, in fact, you know what? Let me write the word. This is to check our work. Let me do it with a text box here. Let me just make sure that we have that note written down here. So to check our work, or I should say to check our solution, we should substitute. This means to replace. We should replace the x and the y with with 7 and 3 in, here's the key word, both equations. All right, now let me show you how that works. I got some other stuff down here that needs to get deleted. What is that? All right, so let me write both equations again. 6x, 6x, and I'm going to put my my x in parentheses, minus 10y is equal to 12. We put x and y. And let me also write the other equation. I'll leave a little bit of space here in just a second. What was the other equation? The other one was negative 5x plus 10y is negative 5. Negative 5x. Whoops. I got a bunch of other stuff here I need to get rid of. I'm so sorry that this computer is so slow because it's dragging everything else down. Some other notes that were on the whiteboard. Sorry, everybody. Let me clear these off. Sorry about all this extra time that it's taken. Oh my gosh. Should have fixed this ahead of time when I messed up. I'm going to clean my whiteboard. Okay, good enough for now. All right, so what did I say? Negative 5x, right? Negative 5x. Any more room? Plus 10y. Was it equal to negative 5 or 5? Anybody remember? I'm going to double check here. I think it was negative 5. Just want to make sure I didn't forget what it was here. Oh, yeah, it was negative 5. Okay, good. All right. So I know it's taking me way too long to write this. I should have had this cleaned up more. All right, so here's my x and here's my y. And I'm going to erase these now and put in different numbers. I'm going to erase the x and put 7. I'm going to erase the y and put 3. I'm going to do the same down here. That's 7 and that's 3. And let's see if this is right. Well, 6 times 7 is 42. Minus 10 times 3 is 30. Well, yes, 42 minus 30 does equal 12. So it works in that equation. It's got to work in both equations. Negative 5 times 7 is negative 35. And that's a 3. That's not a negative 3. That's just a smudge there. 10 times 3 is 30. So negative 35 and positive 30 is equal to negative 5. So it works in that one also. Again, that's that little smudge I didn't get erased completely. That's a 3, not a negative 3, everybody. Okay? Still didn't go away. You can't get that to clear up there. All right. So anyway, let me stop this video and stop sharing. And please, you guys should watch this. Stop it, rewind it, pause it. You can even put comments if you want, or you can just tell me in class if you had a question about how we do this. I'll post a link to it here in a few minutes.